Okay, question 1 of homework U5, binomial expansion. Got to find the first 4 terms in ascending power of 1 minus 2x to the 5, and you've got to give each term in its simplest form. Now we could use, in this case we've got a 1 at the front, so we could possibly use Eiger expansion. The only thing is the question doesn't restrict the second term in its value, so to be on the safe side we'd work with the first expansion using the combinations. So I start this out longhand. First thing we're going to do is 5c5, which is just 1, but 1 to the 5 is my first term, plus 5c4, 1 to the power of 4 minus 2x, strictly speaking to the power of 1. You won't necessarily need to put these down. Note that I've always say each term is plus, and then if there's a minus that comes out later on when we expand each term out. Plus 5c3, 1 to the 3, so the powers are going down for the 1s, minus 2x squared, and plus 5c2, 1 to the power of 2, minus 2x cubed. Okay, now I'll work through each term by term. 5c5, 1 to the power of 5, will get all equals 1. 5c4, 1 to the power of 4. 5c4 is 5. Minus 2x is just minus 2x, so it's minus 10x. Next thing, I've got the minus square is squared, so that's going to be a plus, so the next term is going to be a plus 5c3 times by minus 2 squared, which is 4. So I end up with 40x squared. And then the last term is going to be minus cubed, so that's minus, so it's going to be minus 5c2 on your calculator times by 1 times by minus 2 cubed ends up with minus 80x cubed. So just be fairly methodical with this, although it may seem a little time consuming. Just go through it stage by stage and you're going to minimise the likelihood of making sign errors and the like. Okay, that was part A. Part B, it says x is small, so that x squared and higher powers can be ignored, so it's a standard sort of binomial question. Show that 1 plus x, 1 minus 2x to the power of 5 is approximately equal to 1 minus 9x. Okay, so we're ignoring powers of x squared or above, so I can go for the 1 minus 2x to the power of 5. I can go to the first 2 terms, which is 1 minus 10x, and that's x squared, so we can ignore that, and times that by 1 plus x. If I expand that out, that equals 1 minus 10x plus x minus 10x squared. And that equals, well, I can ignore the x squared, so I have 1 minus 10x plus x, so 1 minus 9x, which is what we want to show. And obviously, being a binomial, it is only an approximation because I'm ignoring any powers of x squared or more.